Okay, today class we're going to begin our lesson on reverse engineering. And so when you're in Canvas and you're in the home page, you should see reverse engineering exercise on the right. If you haven't completed your journal entry, please do that after I go over the lesson today. But for everyone, you should be in modules. When I'm finished with this, you should be in modules. You will scroll down to reverse engineering where you will go back over the information that I'm getting ready to provide for you. So for reverse engineering, it is Unit 3, Lesson 1 and Lesson 2. Okay, the purpose of this unit is to enable the students to identify the core technology subsystems and systems and make up technology devices, reverse engineer a product, and diagnose the problems. So we've already looked at core technologies, subsystems, and systems. Now we're going to look at technological devices and how to use reverse engineering. So let's take a look at the PowerPoint. At this time, you will be expected to take notes, and so you may use your technology journal, and I call it our sustainability journal, or get a couple pieces of notebook paper. By the end of this class, you should have notes on this slide presentation. This is all we're doing this period. So as I'm reading it, you need to take notes. Your notes will be allowed to be housed in your folder. We will have a prep on Monday and the test on Tuesday on systems and reverse engineering. So please pay attention to and take notes on this presentation. Okay, Unit 3, Section 3, Part 1. Why study reverse engineering? What are the steps in reverse engineering? So we have reverse engineering and we have forward engineering. There is a difference. Forward engineering is a process of moving from a high-level abstraction and logical design to a physical implementation of a system. So at this point, we will not be speaking on forward engineering, but I just wanted to make you aware of that it's a process of moving from high-level abstraction, which means using your design briefs that you create to draw sketches and get ideas on what you want your model to look like, to actually making the entire system using your devices that you've designed. Reverse engineering, on the other hand, is the process of taking something apart and analyzing its works in detail. So it's a product that's already designed and put together. You're going to take it apart, analyze how it works, using the intention to construct a new device or a program that does the same thing without actually copying anything from the original. So you're going to take something that already exists, and I imagine you can probably think of some device or game or handheld device that you've seen be reconstructed and actually used in a different way, maybe with some different features. So reverse engineering is the process of taking something apart to analyze its parts, its workings, in detail, usually with the intent to construct a new device, something that does the same thing but does not actually copy the original. Mechanics use this, engineers use this to find flaws in an existing product, to make an improvement to it, to make a better product. I.e. the iPhone went from 1, 2, 3, 4, 7, 8, 9, whatever we have now. So they analyzed its parts to figure out which would be beneficial to keep in the newer version. So why use reverse engineering? The original manufacturer of a product no longer produces the product. The original design documentation has been lost. Some bad features of the product need to be redesigned or designed out of the product. to explore new venues, to improve the product performance and features, to gain competitive benchmarking methods, to get an edge over competition. Maybe that's basically what it means. To update obsolete materials or ones that people don't use them. The bells and whistles that you have on your previous phone may have been eliminated on a newer version. Some versions of a phone may have gone from being big and too big to carry to smaller versions, to finding out that maybe a middle-sized version would be the best between the two sizes. So reverse engineering is to find all of these things out. Reverse engineering includes, and this is where you're going to begin taking your thorough notes, reverse engineering includes identifying the system's components and how they work together, creating a copy or a model of a system in a different form. Reverse engineering includes creating a new model of it in a different form, creating a physical representation of a system, Steps in reverse engineering. You have to make some predictions. What is the purpose of this product? That usually comes from doing some kind of surveying or getting an idea of what customers' needs are. So that's what you would do when you're finding what the purpose would be of this product. How does it work? What market was it designed to appeal to? Is it appealing to young people 18 to 28? Is it appealing to senior citizens who have a specific need for this product? Is it appealing to only those people who have automated cars, ones that don't need a driver? So there's some systems in those kinds of cars. List some of the constraints that may have influenced the design. So these are predictions that you would make. Finding out some things about it ahead of time, thinking of what it is that you might find when you take this system apart. Observation. How do you think it works? How does it meet the design objectives? Why is it designed the way that it is? So you originally made predictions, and those predictions were basically about the input, what goes into a system. The prediction would be, does the output match the input? So that's a prediction for reverse engineering as well. Would the output represent what I wanted in the first place? So now your observation, after you've taken it apart and you've checked out the different components, how do you think these components work together? How do they meet the designed objectives? Why is it designed the way that it is? When you disassemble, you look at how it works, you look at how it's made, you look at how many parts it has, and you look at how many moving parts it has. And if there are any surprises, they'll come out when you disassemble the product. So you need to know all of these things you're going to see when you disassemble the product. There are 5 main things: how it works, how it is made, how many parts it has, how many moving parts, and if there are any surprises. In reverse engineering, you also analyze. That's when you carefully examine and analyze all of the subsystems, all of the parts. What core technologies do they represent? Electrical, electronic, mechanical, structural, fluid, optical. Develop annotated sketches that include the measures and the notes on the components. So you are actually sketching out the different parts of the product, the inside of the product. the components that go into the product. And so once you've sketched it out and you've basically made little notations next to the designs of each to say what they do and how they fit together, you pretty much have explained in graphics how the components of this product work together, and you can see maybe at that point where you could add an additional or make some changes to an existing part so it works better. And this usually comes from the feedback that you get when the original product was made and people made comments or wouldn't buy it because of, or they said they could do without this or that. When you had the newer models of the iPhone where you had to now put the earbuds in the same part where you would put the charger. I don't have an iPhone, but I think that was one of the major problems a lot of students had. They were like, I don't have two separate places to plug in things now. So that became an issue. So these are things that, as an engineer, when you're doing it, reverse engineering, you are looking for flaws. You're looking for things that people are saying are not going to make it something they would want to buy. You may even find electrical flaws, wiring flaws, or things that may cause hazardous conditions or be a safety problem. That's what happens in a lot of cars when they get recalled. Some things have gone wrong with them, and they might have a major factory had taken the car apart to realize that this component wasn't working efficiently. So that happens with cars as well. So you want to then test what it is that you found out. And this means that you carefully reassemble the product, you operate the device, and you record your observations about its performance in terms of functionality, operational and ergonomic, and projected durability. So that's what your major project is going to be for this class, but you need to know that that's one of the steps in reverse engineering. Okay, so you document, and the documentation includes your design goals, the constraints that you think may be a problem, the functionality and the form and the materials that you need for the design, the schematics, those sketches that you drew, lists of materials and components, the flaws and the successes after you've tested it out, identifying any refinements that might enhance the product's usefulness, any upgrades and changes. So these are included in the documentation. You will have a reverse engineering packet that you have to fill out before you do your little video on reverse engineering. So take a look at these and take notes on these, because you won't see this PowerPoint during your test, but you will be able to use your notes. Alright, so just to sum it all up, the steps in reverse engineering. Step 1, make predictions. Step 2, make observations of the object or the product and how it works now, before you reverse engineer it. Disassemble. After you've checked out how it works, you take it apart, look at all the parts. You analyze the parts and how they work together. Test it out. Test out what you've figured out, what you've uncovered. And your documentation will show that you've done all of that. Okay? So good luck on the quiz with the notes. I'm going to show you samples of some of the reverse engineering projects that were put on Padlet last summer.
So I'm explaining how a phone case works. So it's currently on my phone. So there are 3 parts. 2 which are the plastic parts that connect. This is the front cover, and this is the border. They connect and they clasp on this white sort of rubber case. So I'm going to try to take them off as fast as I can. So here's the cover, and here's the border. So you can see they have like these little openings and arms that clasp together, and this is the rubber cover with the holes for the cameras and the flash and the yeah, that's it. That's how it works.
Okay, so there are 3 parts to disassembling the fidget spinner. First, you take out the ball bearings. This one's kind of stuck, so I'm not going to take it out. Then we take off the plastic caps that should be covering all the ball bearings. You can also take this part out, but I'm not going to take it out. And that's all the steps we have to disassembling the fidget spinner.